And now, in this lecture, we'll find out the radius of the circle. In the drawing, we have a circle. Inside the circle, we have chord AC that is equal to square root of 2 units in its length. Chord DB equals to 2 units. And this angle DEB, equals to 45 degrees in its size. Our mission is to find out the radius of this circle. So in order to find out the radius of this circle, we use two rules. The first rule is that the central angle is twice as big as the peripheral angle resting on the same chord. Here we have, again, the central angle is twice as big as the peripheral angle resting on the same chord. Here we have peripheral angle ACB that rests on chord AB and it is equal to alpha. Therefore, the central angle AOB that rests on the same chord AB must be equal to 2 alpha. Why? Because the peripheral angle equals to alpha, therefore the central angle must be equal twice as the peripheral angle, therefore it must be equal to 2 alpha. Why? Because both of those two angles are resting on the same chord AB. Then we also have a second rule, the law of cosines. According to the law of cosines, this triangle ABC could be any triangle. The length for side AB is a unit, side AC equals to B units in its length, and side BC equals to C units in its length, and this angle BEC equals to theta in its size. And so according to the law of cosines, C squared equals to A squared plus B squared minus 2 times A times B times cosine theta. So from this equation, it is very easy to arrive to this equation that cosine theta equals to A squared plus B squared minus C squared over 2 times A times B. I repeat again, cosine theta equals to A squared plus B squared minus C squared over 2 times A times B. So we define the center of this circle. This point is point O, and we join points O and B, O, D, O and A, and O and C by a straight line. Okay. So all those 4 line segments, OB, OD, OA, and OC, they are all the radii of this circle. Why? Because they start from point O, that is the center of the circle, and ends at points B, D, A, and C, and all those 4 points are located on the circle itself. So any line segment that starts from the center and ends at any point on the circle itself, it is defined as a radius. So we define the radius of this circle as R, therefore OB equals to R, OD equals to R, OA equals to R, and finally OC also equals to R. We define peripheral angle ADC as Y over 2. This peripheral angle ADC rests on chord AC, and it is equal to Y over 2. Therefore, the central angle AOC that rests on the same chord AC, must be equal to Y, twice as big as this angle. Likewise, we define the peripheral angle DAB is X over 2. Peripheral angle DAB that rests on chord DB equals to x over 2 degrees in its size. Therefore, the central angle, again, and it rests on chord DB. Therefore, the central angle DOB that rests on the same chord DB must be equal twice as this angle, that is x over 2, that is to say it must be equal to x. In the next step, we'll focus on the upper side of the straight line AB at point E. So on the upper side of AB at point E, we have this angle that is equal to 45 degrees. Therefore, the missing angle must be equal to 135 degrees. Why? Because 135 degrees plus 45 degrees equals to 180 degrees. That is the sum of the angles on the upper side of the straight line AB at point E according to rule number 1. Okay, so in the next step, we will focus on the green triangle, triangle AED, on the green triangle, triangle AD, according to the rule that the sum of the angles in any triangle is equal to 180 degrees. We get that the sum of the angles in the green triangle AD is equal to 180 degrees. That is to say, which angles were inside the green triangle, triangle AD. We have this angle that is equal to x over 2 plus this angle that is y over 2 plus this angle that is equal to 135 degrees, 135 degrees. So in total, the sum of those three angles must be equal to 180 degrees. So x over 2 plus y over 2 plus 135 degrees must be equal to 180 degrees according to the rule that I mentioned. Repeat again. X over 2 plus y over 2 plus 135 degrees equals to 180 degrees. We subtract 135 degrees from this equation and we'll get that here we have x over 2 plus y over 2 equals to 180 degrees minus 135 degrees is 45 degrees. So if we found out that x over 2 plus y over 2 equals to 45 degrees, we multiply this equation by 2 and we get that x over 2 times 2 is x, y over 2 times 2 is y, and 45 degrees times 2 is 90 degrees. So we found out that x plus y equals to 90 degrees, we will subtract x from this equation and finally we will get that y equals to 90 degrees minus x. In the next step, we will implement the law of cosines in the on the pin triangle, triangle DOB. So on the pin triangle, triangle DOB, according to the law of cosines, you get that cosine x equals to r squared plus r squared minus 2 squared. 2 squared is 4. So it is r squared plus r squared minus 4 over 2 times r times r. Repeat again, in the pin triangle, triangle DOB, according to the law of cosines, cosine x equals to r squared plus r squared minus 4 over 2 times r times r. So actually we found out that according to equation number 1, cosine x equals to r square plus r square is 2r square. Minus 4 over 2 times r is 2r square. Okay, so cosine x according to equation number 1, cosine x equals to 2r square minus 4 over 2r square. Here we'll split this expression to two parts. The first part will be 2r square over 2r square, and the second part will be minus 4 over 2r square. So cosine x according to equation number 1 equals to 2r square over 2r square is 1 minus 4 over minus 2 is minus 2, so in the numerator we have minus 2, in the denominator we left only with r square. In conclusion, we found out that according to this equation number 1, cosine x equals to 1 minus 2 over r square. We multiply this expression by 1, which is 2 times 1 over r square. Cosine x equals to 1 minus 2 times 1 over r square. In the next step, we create equation number 2 by implementing the law of cosines on the yellow triangle ACO. The yellow triangle ACO, according to the law of cosines, we get that cosine y equals to r square plus r square minus square root of 2 square. Square root of 2 square is 2, so it is minus 2 over 2 times r times r. Repeat again on the yellow triangle ACO. According to the law of cosines, we get equation number 2 that states that cosine y equals to r square plus r square minus 2 over 2 times r times r. So according to this equation number 2, we found out that cosine y equals to r square plus r square is 2r square minus 2 over 2r times r is 2r square. Okay, so we found out that cosine y according to equation number 2, cosine y equals to 2r square minus 2 over 2r square. Here we split this side of the equation into two parts. So the first part will be 2r square over 2r square, and the second part will be minus 2 over 2r square. So in conclusion, we found out that according to equation number 2, cosine y equals to 2r square over 2r square minus 2 over 2r square. Here we can multiply it by 1 here. We multiply this equation by 1. So we actually found out that according to this equation number 2, cosine y equals to 2r square over 2r square is 1 minus 2 over 2 is or minus 2 over 2 is minus 1, so in the numerator we left only with minus 1. In the denominator we have r squared. In conclusion, we found out that according to equation number 2, cosine y equals to 1 minus 1 over r squared. We have already found out that y equals to 90 degrees minus x, therefore we substitute y in this equation number 2 by 90 degrees minus x. We'll do it now, we get that cosine y equals to cosine 90 degrees minus x, again y equals to 90 degrees minus x. And we know that cosine 90 degrees minus x equals to sinus x. We actually found out in conclusion that cosine y equals to sinus x. Therefore, we substitute cosine y in equation number 2 by sinus x. We'll do it now and we'll get that cosine y is sinus x. And it is equal to 1 minus 1 over r squared. This is equation number 2. When according to equation number 1, we have already found out that cosine x equals to 1 minus 2 times 1 over r squared. So we have here two equations for sinus x and cosine x. Next step, we define 1 over r squared by t, that is to say 1 over r squared equals to t according to our definition, and we get that and we'll substitute 1 over r squared in both equations by t. So according to equation number 1, we get that sinus x equals to 1 minus 1 over r squared. 1 over r squared is t. And according to equation number 2, this is equation number actually 2. And according to equation number 1, we have cosine x that is equal to 1 minus 2 times 1 over r squared is t, times 1 over r squared, that is t. So in conclusion, according to equation number 1, we found out that cosine x equals to 1 minus 2t, while according to equation number 2, we found out that sinus x equals to 1 minus t. In the next step, we will use the trigonometric identity that sinus square x plus cosine square x equals to 1. So we implement this trigonometric identity in those two expressions for sinus x and cosine x in equation number 1 and equation number 2. So according to this trigonometric identity, sinus square x and sinus x is 1 minus t, so sinus square x must be 1 minus t squared plus cosine square x. Cosine x is 1 minus t, 1 minus 2t, so cosine square x is 1 minus 2t squared. And it must be equal to 1 according to this trigonometric identity. The next step, we'll open the brackets on this side of equation number 1. It's actually equation number 3. This will be equation number 3. We'll open the brackets on this side of equation number 3 and we get that according to equation number 3, 1 minus t, this is 1 minus t square of course, 1 minus t square equals to 1 square, that is 1, plus t square minus 2t. Okay? We'll open the brackets of this expression also. 1 minus 2t square equals to 1 square, that is 1, plus 2t square, that is 4t square, minus 2 times 2t is minus 4t, and it is equal to 1. Okay? So here we have t square plus 4t square is 5t square. Minus 2t minus 4t is minus 60. And here we have 1 on both sides of the equation, so 1 will get cancelled, and we left only with this one. So it is plus 1 equals to 0. Repeat again. So note that according to equation number 3, 5t square minus 60 plus 1 equals to 0. We substitute minus 60 by minus 5t minus 1t, and we get that according to equation number 3, t square minus 60 is minus 5t minus 1t plus 1 equals to 0. We take out a common factor of 5t from those two expressions. So 5t was taken out a second factor from those two expressions in the yellow color. What is left from 5t squared after we took from it 5t as a second factor? What is left is actually t. What is left from minus 5t after we took from it 5t as a second factor? What is left is actually minus 1. And here we'll also take out the common factor of minus 1 from those two expressions in the yellow color. So minus 1 is taken out as a common factor. What is left from minus t after we took from it minus 1 as a common factor? What is left is actually t. And what is left from plus 1 after we took from it minus 1 as a common factor? What is left is actually minus 1, because minus times minus is plus. Okay, it is equal to 0. In the next step, we take out t minus 1 as a common factor from those two expressions. T minus 1 is taken out as a common factor from those two expressions, so what is left from 5t times t minus 1 after we took from it t minus 1 as a common factor? What is left? It's actually 5t. And what is left from minus t minus 1 after we took from it t minus 1 as a common factor? What is left? It is actually minus 1 equals to 0. So here we have two solutions that are possible for this equation, equation number 4, or for the value of t. Either t minus 1 equals to 0, and the second solution is 5t minus 1 equals to 0. So according to the first solution, the t minus 1 equals to 0. T minus 1 equals to 0, it means that t equals to 1. According to our definition, t also equals to 1 over r squared. So we substitute t by 1 over r squared in this equation, we find out that t is 1 over r squared, and it is equal to 1. We multiply, so 1 over r squared equals to 1. We multiply this equation by r squared, and we get that r squared equals to 1. R squared equals to 1. We take the root out of this equation, and we get that r equals to plus minus the square root of 1. The negative square root of 1 is minus 1, and the positive square root of 1 is plus 1. So here we have two solutions that are possible, but because of the fact that r is a length and the length cannot be a negative number, we cancel the solution that r equals to minus 1, and we're left only with the solution that r equals to 1. According to the second possibility, we have 5t minus 1 equals to 0. We will add to this equation plus 1, and we will get that 5t equals to 1. We will divide this equation by 5, and we will get that t equals to 1/5. According to our definition, t equals to 1 over r squared, so we substitute t by 1 over r squared in this equation, and we get that t is 1 over r squared, and it is equal to 1/5. We cross multiply this equation, and we get that r squared equals to 5. We take a root out of this equation, and we get that r equals to plus minus the square root of 5. So either r equals to the negative square root of 5, or r equals to the positive square root of 5. Again, but because of the fact that r is a length and a length cannot be a negative number, we will cancel the solution that r equals to the negative square root of 5. And we're left only with the solution that r equals to the square root of 5, and or r could be also equal to 1. In the next step, we'll focus on our drawing, our original drawing. Chord dB equals to 2 units. It is obvious from the drawing that chord dB doesn't pass through point O, that is the center of the circle. Any chord that doesn't pass through the center of the circle cannot be the diameter of the circle. Therefore, dB is not the diameter of the circle because it doesn't pass through the center of the circle. Okay? And we also know that the diameter of any circle is the longest chord of the circle. Therefore, the diameter to r must be greater than dB, that is not the diameter, very simple. Okay, so the diameter to r must be greater than dB, that is not the diameter of the circle. dB equals to 2 units according to what is given as the equation, therefore we'll substitute dB by 2 in this inequality, and we'll get that 2r is greater than 2. We'll divide this equation by 2, and we'll get that r is greater than 1. If r is greater than 1, r cannot be equal to 1, therefore we cancel the solution that r equals to 1. So we left with the second solution that r equals to the square root of 5 units. So in terms of numbers, it is equal to 2.236 units. Okay. Repeat again. The radius of this circle r equals to either square root of 5 units, or in terms of numbers, it is equal to 2.236 units. Okay. So in the next step, I will summarize the lecture. In this lecture, we found out the radius of this circle. It is given as the equation that chord AC equals to the square root of 2 units in its length, chord DB equals to 2 units in its length, and this angle PED equals to 45 degrees in its size. Our mission is to find out the radius of this circle. In order to find out the radius of this circle, we used two rules. the first rule is that the central angle is twice as big as the peripheral angle resting on the same chord. Okay, here we have the rule that the central angle is twice as big as the peripheral angle resting on the same chord. Here, peripheral ACB is the peripheral angle and AOB is the central angle. Peripheral angle ACB rests on chord AB and it is equal to alpha. Therefore, the central angle AOB that rests on the same chord AB must be equal to 2 alpha, twice as big as the peripheral angle that is equal to alpha. Okay? So, in conclusion, the central angle is twice as big as the peripheral angle that rests on the same chord. Very simple. Okay? We have the second rule, that is the law of cosines. According to the law of cosines, in any triangle, this triangle ABC could be any triangle. The length of side AB is unit. Side AC equals to units in itself, and finally side BC equals to units in itself. This angle BC equals to theta. So, according to the law of cosines, the following equation is true: that C squared equals to A squared plus B squared minus 2 times A times B times cosine theta. From this equation, it is very easy to write to this equation that cosine theta equals to A squared plus B squared minus C squared over 2 times A times B. Again, cosine theta equals to A squared plus B squared minus C squared over 2 times A times B. So, we define the center of this circle, this point is O. We join points O and B, O, D, O and A, and O and C by a straight line. Those 4 line segments are all the radii of the circle. Why? Because they start from the center of the circle and ends at points C, A, D, and B. That they are all, those 4 points are located on the circle itself. This is exactly the definition of a radius. Therefore, they are all the radii of the circle. That is to say, the radius of the circle is R according to our definition. So OB equals to OD equals to OA equals to OC equals to R. That is the radius of the circle. Then we focused on the straight line AB, on the upper side of the straight line AB at point E. On the upper side of AB at point E, the sum of the angles must be equal to 180 degrees. So which angles we have here? We have this angle that is 45 degrees plus the missing angle. In total, they must be equal to 180 degrees according to rule number 1. Therefore, the missing angle must be equal to 135 degrees. Okay, then we have here we have peripheral angle ADC that is equal to y over 2 according to our definition. This peripheral angle ADB rests on chord AC and it is equal to y over 2. Therefore, the central angle AOC that rests on the same chord AC must be equal to twice. It's twice as big as this peripheral angle that is equal to y over 2, therefore it must be equal to y. Likewise, we have peripheral angle DAB that is equal to x over 2, and it rests on chord DB. Therefore, the central angle DOB that rests on the same chord DB must be equal to x. Why? Because the peripheral angle equals to x over 2, therefore the central angle must be equal to x. So, we have the green triangle AOB. We focused on the green triangle AED. In this green triangle, the sum of the angles must be equal to 180 degrees. This is true in any triangle, and especially in the green triangle, triangle AED. Which angles we have here? we have x over 2 plus y over 2 plus 135 degrees. In total, they must be equal to 180 degrees according to the rule that I mentioned. I'll repeat again. The green triangle AD, x over 2 plus y over 2 plus 135 degrees must be equal to 180 degrees. We subtracted 135 degrees from this equation and found out that x over 2 plus y over 2 equals to 180 degrees minus 135 degrees, it is 45 degrees. We multiplied this equation by 2 and found out that x over 2 times 2 is x, y over 2 times 2 is y, and this is equal to 45 times 2 is 90 degrees. So, in conclusion, we found out that x plus y equals to 90 degrees. We subtracted x from this equation and finally we found out that y equals to 90 degrees minus x. Then we implemented the law of cosines in the pin triangle DOB. According to the law of cosines, cosine x equals to r square plus r square minus 2 square over 2 times r times r. Repeat again, in the pin triangle DOB, cosine x equals to r square plus r square and 2 square is 4, so it is minus 4 over 2 times r times r. So r square plus r square is 2r square, so cosine x equals to 2r square minus 4. 2 times r is 2r square. So in conclusion, we found out that according to equation number 1, cosine x equals to 2r square minus 4 over 2r square. Then we splitted this side of the equation into two parts. So cosine x equals to, the first part is 2r square over 2r square, and the second part is minus 4 over 2r square. So cosine x equals to 2r square over 2r square is 1. And minus 4 over 2 is minus 2, so in the numerator we have minus 2, in the denominator we have r square. We multiplied this expression by 1. So in conclusion, we found out that cosine x equals to 1 minus 2 times 1 over r square. Then we implemented the law of cosines in the yellow triangle ACO. According to the law of cosines, cosine y equals to r square plus r square minus square root of 2 square. Square root of 2 square is 2. So I repeat again that cosine y equals to r square plus r square minus 2 over 2 times r times r. In the yellow triangle DOB, cosine y equals to r square plus r square minus 2 over 2 times r times r. So cosine y equals to r square plus r square is 2r square minus 2, and 2 times r is 2r square. So in conclusion, we found out that according to equation number 2, cosine y equals to 2r square minus 2 over 2r square. Then we splitted this side of the equation into two parts. The first part will be 2r square over 2r square, and the second part will be minus 2 over 2r square. And again. So actually found out that cosine y equals to 2r square minus 2r square minus 2 times minus 2 over 2r square. 2r square over 2r square is 1. Minus 2 over 2 is minus 1. So in the numerator we have minus 1. In the denominator we have r square. So in conclusion, we found out that cosine y equals to 1 minus 1 over r square according to equation number 2. We have already found out that y equals to 90 degrees minus x, therefore we substitute y in this equation number 2 by 90 degrees minus x, and we found out that cosine y equals to cosine 90 degrees minus x, because y is 90 degrees minus x, and cosine 90 degrees minus x, it is equal to sinus x, and in conclusion we found out that cosine y equals to sinus x. Therefore we can substitute cosine y in this equation number 2 by sinus x. We did it, and we got that cosine y is sinus x, and cosine y is sinus x, and it is equal to 1 minus 1 over r square. And according to equation number 1, we already found out that cosine x equals to 1 minus 2 times 1 over r square. Then we defined 1 over r square as t. Therefore, in the next step, we substitute 1 over r square in both equations, equation number 1 and equation number 2. by t. And found out that according to equation number 1, sinus x equals to 1 minus 1 over r squared is t. Okay? So we substitute 1 over r squared in this equation number 2 by t. Yeah, so we found out that according to equation number 2, sinus x equals to 1 minus t. And then according to equation number 1, we have cosine x equals to 1 minus 2 times 1 over r squared. And 1 over r squared is t, so we substitute 1 over r squared by t. And finally we found out that cosine x equals to 1 minus 2t. Cosine x equals to 1 minus 2t. Then we use the trigonometric identity that sinus square x plus cosine square x equals to 1. We implemented this trigonometric identity in our two expressions for sinus x and cosine x. So according to this trigonometric identity, we get that sinus square x. Sinus x is 1 minus t, therefore sinus square x is 1 minus t squared. Plus cosine square x. Cosine x is 1 minus 2t, therefore cosine square x is 1 minus 2t squared. It must be equal to 1 according to this trigonometric identity. Then we open the brackets of this side of equation number 3 and found out that according to equation number 3, 1 minus t squared equals to 1 squared, that is 1, plus t squared minus 2t. Open the brackets here also. 1 minus 2t squared equals to 1 squared, that is 1, plus 2t squared is 4t squared, minus 2 times 2t is minus 4t. Okay. So here we have t squared plus 4t squared is 5t squared, minus 2t minus 4t is minus 6t, and here we have 1 that is on both sides of the equation, so 1 will get cancelled, and we left only with 1 here. So in conclusion, we found out that according to equation number 3, 5t squared minus 6t plus 1 equals to 0. Then we substitute minus 6t by minus 5t minus 1t. And found out that according to equation number 3, 5t squared minus 6t. Minus 6t is minus 5t minus t plus 1 equals to 0. Then we took out 5t as a common factor from those two expressions, so inside the brackets we left only with t minus 1. In the next step we took out a common factor of minus 1 from those two expressions in the green color, so inside the brackets we left only with t minus 1 equals to 0. Then we took out t minus 1 as a common factor from out of those two expressions, so inside the brackets, so t minus 1 is taken out as a common factor from those two expressions, so inside the brackets we left with 5t minus 1 equals to 0. So here we left two solutions that are possible for equation number 3 for the value of t. Either t minus 1 equals to 0 or 5t minus 1 equals to 0. Okay, those two options. If t minus 1 equals to 0, it means that t equals to 1. According to our definition, t equals to 1 over r squared, so we substitute t by 1 over r squared. And so t is 1 over r squared, it is equal to 1. We multiply this equation by r squared and found out that r squared equals to 1. We took out of this equation and found out that r equals to plus minus the square root of 1. The negative square root of 1 is minus 1 and the positive square root of 1 is 1. So actually r cannot be equal to minus 1 because r is a length and the length must be a positive number. Therefore we cancel this solution r equals to minus 1, that is a negative number. And we left only with the second solution, that r equals to 1. Then according to the second possibility for the solution of equation number 3, we have 5t minus 1 equals to 0. So we added 1 to this equation and found out that 5t equals to 1. Then we divided this equation by 5 and found out that t equals to 1/5. according to our definition, t equals to 1 over r squared. So we substitute t in this equation by 1 over r squared and found out that t is 1 over r squared equals to 1/5. Then we cross multiply this equation and we found out that r squared equals to 5. Then we took out of this equation and we found out that r equals to plus minus the square root of 5. Either r equals to the positive square root of 5 or r equals to the negative square root of 5. But r cannot be equal to the negative square root of 5 because r is a length and the length must be a positive number. It cannot be equal to the negative square root of 5, that is a negative number. So we have only with the solution that r equals to square root of 5, or also we have another solution that r equals to 1. Two solutions that are possible for the value of r. But here we have in the drawing called dB equals to 2 units. It is very easy to see from the drawing that called dB doesn't pass for 0.0. Because of the fact that code dB doesn't pass for 0.0, it cannot be the diameter of the circle. Why? Because any diameter of a circle must pass through the center of the circle. Therefore, dB is not the diameter of the circle, and we also know that the diameter of the circle is the longest chord in the circle. So the diameter 2r must be greater than dB, that is not the diameter. Very simple. The diameter 2r must be greater than dB, that is not the diameter. We define dB, according to our definition, dB equals to 2. According to what is given us in the equation, dB equals to 2. So we substitute dB by 2. And we found out that 2r is greater than 2. We divided this equation by 2 and found out that r is greater than 1. If r is greater than 1, r cannot be equal to 1. So we can send the solution that r equals to 1, and we left only with the second solution that r equals to square root of 5 units in its length, or in terms of numbers, it is equal to 2.236 units. Repeat again, the radius of this circle r equals to either the square root of 5 units, or in terms of numbers, it is equal to 2.236 units. Okay? Thank you very much.